In my JEE days, I had used to simply for most complex number equations I used to do this, but I don't think it is the best approach most of the times. So what we'll do is here multiply both the numerator and denominator by mod z, or rather sorry, conjugate of z, which gives us, and mod z square, let's write that as k, where k is a real number. Now what we'll do is we'll write the numerator as minus 3k plus 6k, which gives us 1, because this thing is same as this denominator, plus 6k upon so now this is a real number, this is real, so for this whole thing to be real, this plus this should also be real, which gives us 2 z bar plus 4 mod z square z equals to 0. No, it should be real, so that means this should be equals to its conjugate, 2z plus 4 z bar, which gives us 2 and as z is not purely, it's not a real number, so z bar cannot be equals to z, that means this thing should be equals to 0, which gives us 2 equals to 4 half. So our answer is 0.5. Obviously we could also have done this by this, substituting z equals to x plus iota y, and then setting the terms coefficient of iota as 0 after simplifying and rationalizing the denominator, or multiplying the denominator by its conjugate, and that would also have given us our answer, but I think this method is simply much better.